Okay, folks, we're going to go have our next talk. This is Tannaz Najafi is going to speak on diachronic emergence in causal set theory.
Thank you. So yeah, thank you for having me, first of all, and for organizing this wonderful conference. It's a real honor for me being here. And as he said, I will be talking about diachronic emergence in causal set theory. So my talk will be very simple, clear, and general, I hope. So the thesis is that I would like to argue is that causal set theory is a theory that certainly presents diachronic emergence, always relative to subcausettes, and it does that without the necessity of there being backward emergence through cosmology. And I will explain all this in detail. So the way I will proceed is by briefly present what is the theory of causal sets. Then I will present Crowther's position and concept of diachronic, or what she calls flat emergence, and I will argue against her. And consequently, I will try to show that there is, in fact, diachronic emergence in causal set theory. And then I will continue by presenting one point that is shared by both Wüthrich and Crowther's paper 2019 and 2015, that there is a backward emergence in causal set theory through cosmology, and I will try to argue against them as well. So causal set theory, as perhaps some of us may know, is one of those prominent theories of quantum gravity that tries to quantize gravity and explain some of the phenomena that interest both the relativistic and the quantum domain, as, for example, at extremely high energy scales or regions with high curvatures, there are quantum effects that are important. And so basically, it's important to have these theories of quantum gravity. I'm not a physicist, but just a general introduction. So what is interesting of causal set theory is that despite other theories of quantum gravity, it maintains that the physical world is fundamentally made of discrete space-time points, and it consists of a partially ordered set of elementary events that is called causal set. So this partial order, despite the name of the theory, is purely a relation of temporal precedence. It is debated, actually. For example, for Wüthrich, it is causal. It's a causal relation, but for Dawker, who is a physicist instead, is just temporal. And I tend to think that is more temporal because we know in philosophy that it is a necessary condition, perhaps, to be before another event to have causality, but is not a sufficient condition, but is a very debated domain in philosophy as well. So I will just present it as a relation of temporal precedence, which, however, is not absolute, though claimed to be compatible with the relativity of simultaneity. In fact, its dynamics is described through the classical sequential growth models, which are stochastic and past finite, meaning that the new elements are continuously coming into existence and they randomly choose a point to be the future of. To give an example, which is more easy. So causal set theory has an initial point that is labeled 0, okay? And after that, we can have basically continuously a random burst of continuous points, okay? And they choose randomly other points to be the future of. And for example, from A, we can have two scenarios, B and C, where the white point is the new birth one, and the red points are those that are connected with the white one, whereas the black ones are not temporally connected with the white one, okay? And so this is what they call asynchronous becoming. Why? Because it is not absolute, and this is the reason why it is claimed to be compatible with relativity. I hope it is clear. If not, I can explain that better. Moving forward, what it is claimed by Crowther, I will follow her because I think she makes important points on this. So basically, she distinguishes between flat and hierarchical emergence, which may be reported as corresponding respectively to the diachronic and the synchronic one. But since we do not have since it is not clear whether there is time in quantum gravity, she rightly introduces the notion of flat emergence, which is supposed to be the counterpart of diachronic emergence, precisely in the theories where we lack a precise definition of time. And with this, it is meant, of course, that what we lack is a relativistic notion of time. We don't know what the physics of time is in these theories of quantum gravities. And she introduces the notion of flat emergence, and basically she tries to argue that there is hierarchical emergence in causal set theory, but not flat emergence. And to explain that, I will just briefly present what is meant by an emergent phenomena generally. So basically, we need to have three criterions to have emergence. One is dependence, the other one is novelty, and last one autonomy. So it is said that E is dependent on B as evidenced by B being approximately derivable from B and or supervenient upon B. And this is important. Then novelty means just basically that E is strikingly qualitatively different from B. And autonomy finally is robust against changes in B, or E is the same for various choices of or assumption about the comparison class B. Now, according to Hoefer, so these are very general and positive definitions of an emergent phenomena. Okay, now we need to make it more precise for the hierarchical and the flat one. So according to her, we get this definition by analog reasoning, but they claim that these reasonings are very different. They are not analog at all. If we start with the hierarchical ones, she says dependence is defined by the coarser grain theory model of structure E. So we have dependence when the coarser grain theory E is constructed from the finer grain theory B. The physics described by the laws of E may be said to supervene on those of E, where again supervenience means that there is no change at E level unless there is a change at the B level, but not vice versa. So basically, it is very much analogous to her definition of the general definition of an emergent phenomena. But for the flat case, she just says that E flatly supervenes on B. Oh, and by the way, E is the emergent level and B is the basis. So what's clear? And that's it. So this is just a definition. E flatly supervenes on B. And flat supervenience means that there would be no change in E in the E state unless there were changes at the B state. So basically what is totally missed is the first part where we had the derivation or some sort of notion of normal dependence that we have that does not hang on the notion of supervenience. And here instead, the definition is just based on the supervenience notion. So now clearly what I think is that the derivability or dependence in general is very much a different concept from that of supervenience. And so first of all, as I said, this is not analogous to the other definition she gave, but also in her general definition she gave here, I don't think that, how can I use the dot? There's no red point. Okay, anyway, in the middle, when she introduces and or, she's also assuming somehow that approximate derivability is similar to supervenience in an analogous way, which is not. So, and in fact, the notion of derivation may be way more general than that of supervenience. If supervenience requires change at the B level to have emergence at the E level, this is not necessary for derivation. And the point is crucial since Kreiter's main argument is precisely that there is no flat emergence in causal set theory because of the intrinsic stochastic nature of the sprinkling dynamics, where points births she assumes are independent from their ancestors. And in fact, she says, but the dependence conditions of emergence is not satisfied. This is because of the probabilistic nature of the dynamics, which ensures that conditions of flat supervenience fails. And she doesn't really give an argument, but I think that her argument is presumably that this is due to the fact that we may have new random point birth at some successive level E compared to B without, however, a necessary change in B. And this is precisely what the sequential growth is about. But even if this last point is true, it is nonetheless poorly explained why there is no causal or dependence relation between the new and the old points. And my point is precisely to highlight how much her definition of flat dependence is not analogous, as I have tried to show. And a more correct and more analogous definition of it would lead us into another conclusion, to the opposite conclusion. For example, I think that if we have a more analogous and a general definition of the dependence condition for the flat case, like this one, E is flatly dependent on B as evidenced by E being approximately derivable from B and or supervenient, but as I said, I'm not happy with the and or. Then we will end up in another conclusion. So if we focus on the first half of the definition, what is important is to get, sorry, I'm a little bit confused. So yes, what is important is to get a definition that can go hand in hand with the other two criterion of emergence. So if you consider the case for the hierarchical emergence, there the notion of approximate derivability meant that a state description in E is approximately derivable from some basis level B, which also means that E is a non-completely precise description of it. Okay, so it's approximate, which also means that in some relevant features we're interested to, and from some point on, we can consider that the totality of points as being our relativistic spacetime in the case of hierarchical emergence. And this despite the fact that what we have, even if it is something incredible near to it, yet it may also be slightly different. And to make clearer my point, I think that it is the same thing basically to say that E is approximately derivable from B and to say that E is probably derivable from B. Okay, so both for the hierarchical and diachronic case. So thus the same in an analogous way applies for the case of diachronic or flat emergence. In this case, though, rather than having vertical emergence, as for the synchronic one, we would have horizontal emergence at different times, where new points verse E are probably approximately derivable from all points B without the need of having changes at B level to have changes at the A level or before and after, okay? So basically, this is what is meant by dependence. And furthermore, it is also not clear why, just because it is stochastic, there is no dependence at all. And we have many examples of this in the philosophy, and one of this is given by Lewis. He defines the relation of causal dependence that is sufficient but not necessary for position in terms of probabilities. And he says event E is causally dependent upon event C, just in case C and E actually occur at times T and T prime respectively. At time T, the probability of E was X. If C hadn't occurred, then at time T, the probability of E would have been less than or equal to Y. And so basically that gives the idea of the fact that if we have probabilistic relations, then we have also some sort of dependence between one event and another. So there is no reason why we need supervenience to have dependence. So yeah, although the theory of Lewis was certainly built on a non-conditional and rather deterministic notion of probabilities, in fact, he was a frequentist. Okay, this is also worth mentioning. Nonetheless, I think that this definition per se can be applied in both cases for indeterministic and deterministic cases. Okay. Furthermore, since it is about time, the passage, and the emergence, so the conference is about that. We know that the Crowther introduced the notion of flatness because we don't have the notion of time in quantum gravity. But I'm not also that convinced if what she says is clear enough or original. Okay, so the idea of flatness was never completely specified by her, in fact. And her statement was only that flat supervenience means that there would be no change in the E state unless there were a change at the B state, but not vice versa. So this is flat supervenience, and the only moment when she defines flatness. Okay, and then of course, even by her own words, she defines supervenience in the same way. Basically, there is no change in E unless there was a change in B, which is the supervenience slogan. There cannot be an E difference without a B difference. So basically, she defines flat emergence only based on supervenience. So that's really the same definition. So it's basically not, it doesn't say anything more about this concept of flatness that is supposed to solve a problem of time in quantum gravity in order to have diachronic emergence, okay? But to add, I also don't fully see the need of having a non-temporal definition of a diachronic emergence in causal set theory. And in fact, in causal set theory, you have temporal relation. They are not absolutes, but restricted to some subsets, as I have shown earlier. All points come after or before some other points. Of course, this is not a definition that like a notion of time that is similar to that of relativity, because in relativity we have it's continuous, basically the space-time, whereas here is discrete. Of course, it's different, but still there is a notion of time that is actually even nearer to what we used to think of time, as in the Middle Ages, for example. We had earlier and later parts. There are many examples of that, and I don't see why we cannot use this notion of time also in, here, just because it is not related to relativity in any ways. So the first conclusion is that if we maintain my definition of flat dependence that does not strictly hand on supervenience, we can have diachronic emergence that is stochastic in causal set theory, reflecting in this way Crowther's argument. And I hope that you agree with me. And then this is the second part already. So here I will try to argue that basically, I will argue against Christian Wüthrich and Crowther's paper, as I have said, because a further claim that Crowther's makes just after arguing that there is no diachronic emergence in causal set theory is by saying that, well, we can have that only if we reach the future infinity. Okay, so once all the points are born, basically there is emergence. And this is also an indirect argument against the becoming view that is claimed by causal set theory to exist. Okay. So in fact, what she says is that together with Crowther, that there is backward flat emergence. And this is because determinate existence can happen only when all the causette has reached its future infinity process of points words. Crowther says, interestingly, however, there is a case to be made that the past contracting universe emerges from the expanding phase via the Big Bang, or rather Big Crunch, and in its future, this is because there is a sense in which the past events depend on the Big Crunch event. All past events pop into determinate existence once the past is birthed, which is exactly the same conclusions Wüthrich reaches. And up to after some consideration about the fact that existence cannot be vague. And the Wüthrich's argument was that first, the alleged becoming aspect in causal set theory has sense only if the events are determinate and not vague. However, causal set theory gives us a model that is ontologically vague, since it is fundamentally stochastic. Nonetheless, there might be a way of having determinate events only when the causettes are finite. Thus, we may have ontological indeterminacy without vagueness only when the causettes have reached their future infinity, and those are finite. So basically, we can have real emergence, like get relativity, okay, out of causal set theory only when the future infinity is reached. And once more, there is no becoming. Interestingly, though, Wüthrich's argument strongly relies on a philosophical assumption which interprets physical randomness as metaphysical vagueness, a position that is also reached through analog reasoning, and that is not exempt from controversies. So in Wasserman, I think, so I hope that it's clear that so he assumes that basically it is ontologically vague because it's fundamentally stochastic, and actually he says that, okay, this is a clear assumption that he makes. And I think that this analogy is clearly presented in a paper of Wasserman of 2015, where he says, now, if the laws of nature are indeterministic and the laws of nature are analogous to the laws of metaphysics, then we should ask whether the laws of metaphysics could be indeterministic as well. What would it mean for the laws of metaphysics to be indeterministic? Well, in the case of metaphysics, the counterpart of the initial state of the universe would be the totality of fundamental facts. To say that the laws of nature are indeterministic is to say that the initial conditions, together with the laws, fail to determine all of the non-initial conditions. So to say that the laws of metaphysics are indeterministic would be to say that the fundamental facts, together with the laws, fail to determine all of the non-fundamental facts. And then he gives the example of the clouds, where he says basically that combinations of particles basically wouldn't tell us whether we end up having cloud or something else, like the same combinations or like structures of these particles, the same things may lead us to with different things at a non-fundamental level. And those we would have vagueness. Nonetheless, I think that this analogy neither is nor should be accepted. And in fact, I think that there is one big disanalogy, and that is that while in or determinism about theories requires dynamics, vagueness is static. So we don't have cases in physics where there is indeterminism at a static level. And basically what Wasserman is just doing with these analogies is trying to make sense of indeterminism or determinism in a static way rather than in a dynamic way, because in a dynamic sense, we wouldn't have vagueness. And I think the point is fundamental, since metaphysical indeterminism can be disentangled from vagueness when one considers states or facts at different times rather than at the same time. And what has led many philosophers to consider vagueness to be the counterpart of indeterminism is the idea that grounding or ontological dependence is a relation that can hold only in a hierarchical and static way and never in the dynamic way. But I really don't see why. And in fact, there are also more interesting and powerful conceptions of grounding that can conceive of metaphysical indeterminism also in a dynamic way and without ending up to vagueness. And Bolzano, for example, is a very famous example of a person who has argued for partial intrinsic grounds as metaphysical counterpart of physical indeterminism, and he didn't end up in vagueness. So I really don't see why a lot of people in the philosophical community of physics, they just assume that this is true. No idea. So thus, given that Wuttrich's claim of vagueness in causal set theory is arguably controversial, if not one of the most controversial issues in the philosophy of probabilities, and also because even nowadays in the contemporary philosophy of probability, we have many examples of philosophers who try to put together causality, dependence, grounding in some ways. So there is a very big literature about that, and still it is assumed that they don't exist. I think that his argument in favor of backward emergence also relies on Shaky assumptions. And without the vagueness assumption, we may clearly argue in favor of a forward emergence that is certainly stochastic and allows becoming, though is not vague and does not need to be finite. And so, yeah, to conclude everything what I've done is that I try to show that causal set theory is a theory that certainly presents diachronic emergence, always relative to subcausates, because it cannot be absolutes, okay? And it does that without the necessity of there being backward emergence through a cosmology. And I've tried to say that because Crowther, by saying that Crowther's definition of dependence is not very linear and coherent with even herself. And it has also the problem that flatness is not defined at all. And there can be dependence also in stochastic approaches without the need of supervenience. And the metaphysical counterpart of randomness may not be vagueness. This is a little bibliography, and thank you.
Anyway, sorry, trying to fix the pointer. Questions?
This is a question about Crowther's notion of supervenience. Does it violate the conjecture that these folks have about the uniqueness of the mapping into space-time? Because that conjecture says that for each causal set, it should map to exactly one space-time manifold, right? That each one that does map should just map to one. And if her claim about the failure of supervenience is right, then multiple space-times would map to a single causal set, because there'd be a difference at the space-time level, but no difference at the causal set level.
This is an interesting question. I have to think about it. This was about the novelty, not the autonomy condition, right?
This is about flat supervenience. So just flat supervenience says no difference at the top level without a difference at the bottom level.
It's supervenience, okay.
Yeah, and so she says there's a failure of supervenience, right?
Yeah.
But it looks to me that if supervenience here fails, then that conjecture fails.
Yes.
I'm not sure, but like,
I would like you to be right, but sounds likely.
Did Chris remove me as a co-author from that paper? I think I wrote. I was looking at that. I thought, boy, that looks familiar. But I think, isn't that?
No, repeat that. Sorry, slowly.
Did Chris remove me as a co-author from that paper? I think
No.
it's not just by him. I think it's also by me.
Oh, really?
But
I'm so
anyway, it
sorry.
doesn't matter. But I
No,
was saying
I
it looks.
Whoop. Oh, sorry.
Yeah. See, I knew it looked familiar.
Oops.
So yeah, I'm not sure what with the vagueness. I mean, well, let me just ask what your position is on this. So if I've got a cost set, say it starts off with this of elementary set, then there's so I'll give two stories. So one is it births another element, say Alice's birthday party, then causally or temporally, and then one where now it's a space-like one is birth, Bob's birthday, and then they both temporally precede a birthing then of a kind of big crunch, right? So it's just a little.
Mhm.
And then I give another story where Bob's one happened first, and then Alice's happened space-like related, and then we go to the same big crunch type thing. So now in the causal set group, that would violate relativity, right? Because now I have these two space, so if there was a fact of the matter between those two stories, then there'd be a fact of the matter about who got birthed first, Alice's birthday party or Bob's birthday party. And so then they gauge it, right? So they then say, well, as long as the probabilities of the chain are the same, then those are actually literally somehow they're literally the same. And so there's no fact of the matter about which path was the one taken. And then as I remember it, we were thinking, well, that then only makes sense really sort of when the whole set is there. And there's not then a fact of the matter about. So then it seemed to us that metaphysical vagueness seemed to make sense then as to what. So if you then said, well, which happened first, Alice's party or Bob's party, and then they answered no fact. There's no fact of the matter. Well, then it seemed to us in some sense metaphysically vague, but I don't really.
I'm not sure if I remember that example precisely because I just took the argument that Crowther was also assuming. Okay, so that was the connection. But I don't see why there is vagueness because from what I understood from causal set theory, but correct me, having 2 points that are not temporally related doesn't mean that they are simultaneous or that they are the same, because you said at some point that they are the same.
Oh, well, yeah. So they've got the time and the Poisson sprinkling. And so from that point of view, you could talk about one happening first, but then they want to say, well, no.
But from what I understood from,
and so it's not a fact of the matter about which one happened first.
Yeah, but from what I understood from causal set theory, you can never say what confirms first or later, right? Just relative to causates. Okay.
Right. But what is that call set? So we have, we can't say sort of like in the middle, which one, so between the, so I've got a call set with a one point and then another, and then ending with another point. In between, I can't say what is, what. It's only when I've got the whole completed one.
No, because I think that you're assuming that indeterminacy basically comes together with vagueness. Like, what does that mean in between? Like for me, there is no question of in between. It's just random, without the need of being vague. And when a point is birthed, is born, then it's like what it is, but it's not because it is intrinsically like, for example, in Bolzano, okay, he had an interesting view that okay, every proposition do exist, have truth value, okay, so he had an eternalist picture, okay, but he believed that it was stochastic, okay, meaning that these propositions that have truth value and everything, they have also a probabilistic property on them, and that's what it is. It doesn't mean that it's vague.
I know, but I'm saying that, yeah, so it's all probabilistic, but I'm saying that because they want to have this treat it as gauge, that's what made us think it was vague.
No, I'm not sure I understand.
What, so I'm going to a birthday party and I've got two possible presents to bring, one for Alice or one for Bob. Which one should I bring? And then they say there's no fact of the matter about which birthday happens.
Yes, but that doesn't mean that it happened or it's there or there's something vague there that we don't know, or that is both, or that is none. Because it is like, becoming, and there is still not yet anything, but it's just probably something. And that to me makes sense.
Let's see.
I was just so thanks for the talk. It was kind of a follow-up. I mean, maybe it's something I want you to clarify that may be helpful, because what's related to that. So it seems that you were assuming that there is this distinction between, which is right, between vagueness as a static phenomenon and indeterminism as a phenomenon that is related to the dynamics. And I agree on this. But I think maybe if I understood, I didn't read Chris and Craig's paper, but if what I understood from what he was saying is that what they want to say is that in this case, at least locally, there is indeterminacy or vagueness. I don't know why they use vagueness. Bad you should have used indeterminacy. It's much better. It's not that bad. It's not that bad. But I think vagueness in that kind of context, it's actually referring to this static phenomenon again, not as okay, right?
Yeah.
Cool. Then in that case, the argument you were having about the fact that it depends on the stochastic dynamics do not apply, because in this case, as far as I'm understanding, and again, this is a clarification. It would be better. No, I'm kidding. You can just make, no, it's just, it creates, indeterminacy may create some confusion because it indeterminacy and indeterminism. But vagueness is like, I guess it's the macro phenomenon sorry, the other way around. Indeterminacy is a macro phenomenon. Vagueness is one of the instances. But again, so from the argument you were having, I was kind of assuming that you were suggesting that this depends on the dynamics. The vagueness they refer to depend on the dynamics.
Yeah, basically, if I understood correctly, the vagueness can be avoided once they bump into determinate existence once the future infinity is reached. Okay, so there is no dynamic anymore, right? Because it's there, like a block. So yeah, the dynamic aspect, it's also in contrast with determinate existence, sure.
But locally, there is no fact of the matter about which one is the correct one or which one is the one that will eventually be taken, right? So this is a static phenomenon, right?
I don't understand.
It's a static kind of indeterminacy, the one they are speaking about.
No, if it is static, then they are determinate. No, so the Wassermann, okay, I think you're confusing the analogy with Wassermann with what the paper of Wuttrich and Craig Callender, they are saying. Yeah, sorry for that, by the way. So embarrassing. And basically, Wassermann is doing an analogy, okay, with from physical indeterminacy that is dynamic. Okay, it's at different times, normally, this in physics. But with metaphysics, the only thing they say, okay, just like shift it into mereology, basically, okay, basic fundamental facts and the non-fundamental facts, it is static, and so we get vagueness because we can have multiple non-fundamental facts, like we have multiple later events at later times. We have multiple non-fundamental facts. And then they get a vagueness, but only if they assume, in fact, indeterminacy at the fundamental level, okay? But what they are saying, and this is also interesting, I haven't been clear, so thank you, is that whenever, and this is also what happened later in the philosophy of physics community, that wherever there is a bit of randomness, then there is vagueness, whether it is dynamic, whether it is static, it doesn't matter, it is vagueness. And I think it's just too quick. But we can talk about it. So, and I think, yeah, there are just many examples also with in the past with Sano, but also in, nowadays that basically make a distinction in between these two notions. So I hope it's clarified.
No, it's
okay.
it's okay.
I just had one quick comment about terminology, just to avoid confusion if you're talking to physicists, which is that sequential growth is not a necessary part of causal set theory. It's not part of the definition of causal set theory. It's a proposal within the general
Yes.
doctrine.
No, absolutely.
I've heard other people.
Sorry.
make the
Thank
same-
you.
Okay, yeah, so happy enough with the ontic indeterminacy and the stochastic causation. There's plenty of views like that. I wanted to ask a bit about the backward emergence, particularly sort of how worrying backward emergence is going to be kind of generally. So there are lots of instances where, say, we thought Lance Armstrong had won the Tour de France. It turns out Lance Armstrong has never won the Tour de France because winning the Tour de France depends on not being stripped of it later. So there are lots of kind of routine cases of backwards emergence at the macro level. How worried should we be if that ends up being part of the picture?
Can I say that I have no idea? Because I need to understand better the tour that you said.
Oh, so it's just a really famous case of a man who competed in a bicycle race and was famous for having won it, and then turned out to be on drugs the whole time. And so the committee said, "You have not won this. You have never won it. We strip you of the award and make it the case that you never had it." So it's just a famous instance of something where the facts about what happened in the past changed years later.
Okay, I'm not sure if that is related to emergence, though. I hope someone from the public can help me on this. So,
I don't look to them for help. I mean,
but
seems like
I just think that it's different cases. It is backward, but it is not emergence, I would say. Right. If anyone wants to argue against that.
yeah, so something becomes determinate that wasn't previously determinate.
Thank you.